Hey guys, I'm making this video series for VTU M3 students, and if you're 21 scheme students, then you will be writing the exam for the first time, 21 or 31, and for 18 scheme students who have M3 backlog. And if you like these videos, please subscribe to our channel and share these videos with your classmates and friends so that it will help them also. Okay, so in this question, f of t is given as square root of t minus 1 over square root of t whole cube, and we need to find f of s, which is Laplace transform of f of t. And what is the Laplace transform? It is the integral of the product of f of t and e power minus st with respect to t from 0 to infinity. But we don't actually need to integrate anything because we already have a list of basic Laplace transforms, which is one of which is Laplace transform of t power n. Okay, I think this is going to be useful here because square root of t can be written as t power 1 by 2. So Laplace transform of t power n is gamma of n plus 1 by s power n plus 1. Okay, and you know it as n factorial by s power n plus 1, and this is a more general case. This is a specific case when n belongs to a positive integer. If n is 1, 2, 3, 4, then gamma of n plus 1 is actually n factorial. Okay, but in generally, if n is fraction, in this case, we need to use gamma of n plus 1 by s power n plus 1 formula. Okay, so this is not square root, this is gamma function. Gamma function is another integral. You will learn it in the future, but for now it is just an operator, okay, like log. Okay, so we need to use this to solve this. Okay, first let us simplify this. Okay, how do you do that? A minus b whole cube. What is the formula for a minus b whole cube? It is a cube minus 3ab a minus b minus b cube, all minus signs. Okay, so this is the formula for a minus b cube that you have learned in algebra very long ago. So let me rewrite this as a cube minus 3a square b plus 3ab square minus b cube. Okay, I did not directly write this formula because it's more easier to remember, but this is more easier to solve. Okay, so that's why I wrote the both the formulas. Okay, so using this, what will happen to my f of t? F of t is square root of t can be written as t power 1 by 2 cube minus 3 into a square, that is t power 1 by 2 square into b, which is 1 over square root of t. It can be written as t power minus 1 by 2. Okay, because t power square root of t is t power 1 by 2. It is in the denominator. So whenever you bring something from denominator to numerator, sign of the power changes. So plus 1 by 2 in the denominator will become minus 1 by 2 in the numerator. Okay, then plus 3 into a is t power 1 by 2, b square is t power minus 1 by 2 square minus b cube, which is t power minus 1 by 2 cube. Okay, so we have laws of exponent, okay, to evaluate these. That is a power m whole power n can be written as a power m into n. That is first law. And another one is, if you have a power m into a power n, same base, different power, then the powers gets added. If you have product, okay, multiplication of same base, different power, powers get added. Okay, so using that, I will get f of t as t power 3 by 2. Okay, 1 by 2 into 3, 3 by 2 minus 3. 1 by 2 into 2 is 1. So t power 1 into t power minus 1 by 2 is t power 1 minus 1 by 2, which is t power 1 by 2. Okay, so you can do one more step here, but I think you get it. Plus 3 t power 1 by 2, t power minus 1 by 2 into 2. Power of power is multiplication. Okay, power of power is multiplication. So 1 by 2 into 2 is 1, so minus 1. And if you bases are same, powers get added. So it is 1 by 2 minus 1, which is t power minus 1 by 2. Okay, and here it is power of power is product. So that is minus 1 by 2 into 3 is minus 3 by 2. Okay, so this is the f of t, given f of t after simplification into individual terms. So if you take Laplace transform of this, you will get Laplace transform of f of t is f of s t power 3 by 2. T power n means gamma of n plus 1 by s power 1. So that is 3 by 2 plus 1 gamma over s power 3 by 2 plus 1. Okay, minus 3 t power 1 by 2. In place of n, I have 1 by 2. So that is 1 by 2 plus 1 gamma over s power 1 by 2 plus 1 plus 3 t power minus 1 by 2. N, in place of n I have minus 1 by 2. So that is minus 1 by 2 plus 1 gamma over s power minus 1 by 2 plus 1. Blindly stick to the formula. Get the formula correct and then stick to it. That's it. So minus t power n. In place of n I have minus 3 by 2. So that is minus 3 by 2 plus 1 gamma over s power minus 3 by 2 plus 1. Okay. So this can be written as a gamma of 5 by 2 over s power 5 by 2 minus 3 gamma of 3 by 2 over s power 3 by 2 plus 3 minus 1 by 2 plus 1 is gamma of 1 by 2 over s power 1 by 2 minus 3 by 2 plus 1 is minus 1 by 2 gamma over s power minus 1 by 2. Okay. So now we need to find gamma of these values. Okay. So when it comes to gamma, as I said in the previous video, you need to remember three things. Okay. So that is gamma of 1 by 2 is simply square root of pi. This is the only value we know of gamma for us to remember. And then using this, we have to get the value of 3 by 2, 5 by 2, and minus 1 by 2. How do you do that? So if you have n plus 1 gamma, it can be written as n into gamma of n. Okay. So this is a for n greater than 0. So this is to find 3 by 2, gamma of 3 by 2. How do you find gamma of 3 by 2? Or let me find gamma of 5 by 2. So gamma of 5 by 2 can be written as gamma of 5 by 2 can be written as 3 by 2 plus 1, right? That is n plus 1 can be written as, so if you compare these two, n is 3 by 2. And this can be written as n gamma n, that is 3 by 2 gamma 3 by 2. And gamma of 3 by 2 can be written as 1 by 2 plus 1, right? And if you compare these two, n is 1 by 2. So that is 1 by 2 into gamma of 1 by 2. Gamma of 1 by 2 we know. Okay. So this is how you get the value of gamma. Okay. Iterative, repeated process. So gamma of 3 by 2 is 1 by 2 into gamma of 1 by 2, which is square root of 5. So you can write as square root of 5 by 2. Okay. So that is gamma of 3 by 2. What is gamma of 5 by 2? 3 by 2 into gamma of 3 by 2. Gamma of 3 by 2 is square root of 5 by 2. So it will be 3 by 4 square root of 5. Okay. So this is gamma of 5 by 2. Okay. I hope you got it. You have to use this formula for n values greater than 0. If you have negative in the gamma, okay, so then the same formula, a little bit of change. So minus n, gamma of minus n is n plus 1 gamma over minus n. Okay. So this is for n less than 0. So we need to know gamma of 1 by 2 pi. 1 by 2 is square root of pi. Gamma of n plus 1 is n square n gamma of n. And gamma of minus n is n plus 1 gamma by minus n. Okay. So using this, now I have gamma of minus 1 by 2, right? So it is minus 1 by 2 plus 1 gamma over minus 1 by 2 using this formula. Wherever n is there, I would substitute minus 1 by 2. So this can be written as gamma of 1 by 2 over, and this minus 1 by 2 can be written as minus 2 here. Okay. 2 in the whole denominator will come to numerator, minus will come to numerator. So gamma of minus 1 by 2 is minus 2 gamma of 1 by 2, which is gamma of minus 1 by 2 is minus 2 as it is. Gamma of 1 by 2 is square root of pi. Okay. So this is one more value. Okay. So actually my f of s is, where can I write this? Let me just write this here only. F of s is gamma of 5 by 2 is 3 by 4 pi, 3 by 4 square root of pi by s power 5 by 2 is s square root of s. Okay. Again this follows from these two, this rule actually. Okay. Minus 3, gamma of 3 by 2 is square root of pi by 2. So that is 3 by 2 square root of pi by s power 3 by 2 can be written as s square root of s. You don't need to write it like this. You can just leave it like this. No problem. I'm just writing it here. So plus 3 gamma of 1 by 2 is square root of pi by s power 1 by 2 means square root of s minus gamma of minus 1 by 2 is minus 2 pi. So this minus will become plus 2 square root of pi, and s power minus 1 by 2 in the denominator will become s power plus 1 by 2 in the numerator, and s power plus 1 by 2 is square root of s. Okay. So you cannot leave it here. Denominator, this is all right, but you have to evaluate gamma values. That's what asked in the examination. Examination, you cannot just leave it at gamma values. You have to find the gamma values using these three formulas. Okay. And then write it like this in terms of square root of pi values. Okay. So this is how you solve t power n Laplace transform when n is a fraction. Okay, let's see one more problem where we have fractions in the power. So the simplest way to improve your CGPA is by studying the previous year question papers, and this works for all branches, any subjects, and for engineering math subjects, especially for M3, we have prepared an e-book, solutions to previous year question papers and model papers, that I think will help you enormously. Okay, I will leave the link to the e-book in the description. Please go check out our e-book. And if you are somebody who don't want to take any chances and prepare thoroughly for the examination, and if you are somebody who needs help understanding the solutions that are written in the book, you can check out our course, which is amazing and self-paced and very affordable. And I will leave the link to the course in the description. Please go check out our course.